So let's check to see if you expanded this correctly as we left off in our last video. You should have gotten this. So you can pause this video if anyone has any questions and help each other figure out where your mistakes were. But otherwise, let's move on and look at actually a pattern that's emerging in the coefficients. So we're going to look at each of these expansions, and I've just made up a little graphing calculator file here so that we don't have to do each of them by hand. A really neat function of your on-computer graphing calculator is that it can actually expand these expressions. So for example, if I highlight this and I go to math, expand, it will expand it out into a squared plus 2ab plus b squared. Just ignore these numbers here. All that is doing is assigning a value to a and b of 1. It's just the way the program works, but we don't have to worry about those. So let's see what these expanded will be. Of course, a plus b to the exponent 1 will just be a plus b. And a plus b to the exponent 0 will be, everyone, 1, because anything to the exponent 0 is 1. We've already seen this one, but we can check that our answer is correct. 1, 3, 3, 1. And here, here, here. And we're going to leave this last one to the power of 7 as an exciting mystery, which we'll see in a few moments. Now, what I want to do is we're going to rewrite just the coefficients of these expansions, just to see if we can recognize a pattern in the coefficients. So from this expansion, obviously there's only one coefficient, that was 1. Here, there was 1a and 1b. Here, there was 1a squared, 2ab, and 1b squared. And then we had 1a cubed, 3a squared b, 3ab squared, and 1b cubed. And then here we had 1, 4, 6, 4, and 1. If we look back, what did we get for 5? Well, we have 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, and 1. And let's look at the 6. We get 1, 6, 15, 20, 15, 6, 1. Now what we're going to do now is I'd like you to pause the video and just take a couple minutes to think to yourselves and to discuss as a class some of the patterns you see here. So go ahead and pause the video and discuss that for a few minutes. Okay, so hopefully you noticed a few things. It's clearly symmetrical, right? It's 1, 5, 10, 10, 5, 1. It's mirror image on both sides. But the really interesting thing happens when you look at the row and then the next row and the next row. If you haven't quite seen that pattern that happens from one row to the next, especially the way you've noticed I've maybe written these numbers, take a few more minutes to think about that. You can go ahead and pause the video and try to predict what a plus b to the power 7, what its coefficients will be. So try to predict this row and go ahead and pause the video. Okay, let's see if you are right in your prediction. Let's expand this. And we get 1, 7, 21, 35, 35, 21, 7, and 1. So hopefully you've noticed that if I take 1 plus 6, I get 7. 6 plus 15 is 31. 15 plus 20 is 35. 20 and 15, also 35. 15 and 6, 31. And 6 and 1, 7. And 1 and nothing is 1. Oh my goodness, that's the coefficients. So this is a really cool thing called Pascal's triangle. And it is just a really easy way to remember all the coefficients of the binomial expansions. So that means that we don't have to do this by hand every time. We can just remember this triangle, and you don't even have to memorize it, because if you know 1 and 1, 1, and maybe 1, 2, 1, then you can construct the rest of this triangle really quickly without too much trouble. So let's see how this is possibly going to help us. Well, first, let's go back and look at this now. We're going to look this time at the pattern in the variables. So here we have a squared, then ab, then b squared. A cubed, b, a squared, a, b squared, b cubed. So you can see what's happening to the power of a. The power of a is decreasing 1 each time. And look at the power of b. B to the power 0, b to the power 1, b to the power 2, b to the power 3. And then Pascal's triangle gives us our coefficients. So let's look at an example. Let's say we wanted to expand 3x minus 1 cubed. How would the binomial expansion help us? Well, instead of writing it out and doing it all by hand, we can first write down the coefficients. They're going to be 1, 3, 3, 1. And I know for the first thing, I'm going to have the first term to the power 3 and the second term to the power 0. So I'm going to have 3x all cubed, not 3x cubed, 3x all cubed, and then negative 1 to the power 0, which of course will be 1, so you don't really have to write it down, but I'll just do it to show you. Okay. Now, in the next term, we'll have 3x squared and negative 1 to the power of 1. Now, in the next term, we'll have 3x to the power 1 and negative 1 to the power 2. And then finally, 3x to the power of 0 and negative 1 to the power of 3. And now all we have to do is simplify these. So 3 cubed is 27. So it would be 27 x cubed plus 3 squared is 9 times 3 is 27 times negative 1 is negative 27. X squared plus 3 times 3 is 9. Negative 1 squared is positive 1, so it's just plus 9x. And then here, 3x to the power 0. Be careful here. This is where a lot of people make mistakes, okay? That's all equal to what? 1. And then negative 1 cubed is negative 1. So the whole thing's negative 1. And there, we're done. One step. So hopefully this will make your lives of expanding binomials for the next 2 years and beyond much easier.